Hello, my name is David Ingram. I am a consumer safety officer with the United States Food and Drug Administration. And it is a great pleasure for me to be here to speak with you a little bit about our agency's perspectives on soil health and how soil health can directly um, contribute to the microbiological safety of many of the commodities that FDA now regulates. I work within a center in College Park. We're housed within the Center for Food Safety and Applied Nutrition, where a group of us largely regard ourselves as the F in FDA. Together, we share a common mission to promote, and protect the public health by ensuring the nation's food supply is safe, sanitary, wholesome, and honestly labeled. It's quite a large task, especially when you consider that FDA regulates over 80% of the food supply. Those commodities you see in red, as they are grown directly in soil, do directly reflect the quality of the soil, not only in terms of nutritional content, but potentially toxicological, microbiological, heavy metal safety. And we do have programs to handle all those contaminants. We'll talk mostly today about the microbiological safety, but if you are interested in understanding more about our other programs for toxicological and chemical, including pesticides, I encourage you to reach out. What you see here are the main pillars of probably, well, not probably, definitely one of the most groundbreaking pieces of legislation to affect food safety in the last 70 plus years, Food Safety Modernization Act. Here you see the main rules and regulations that truly does provide FDA a brand new set of tools to help regulate foods from the farm all the way to your tables. Now, we do stop at your front door. We will not go inside your homes to understand the hazards associated with your cold chain storage in your fridge or the microbiological safety of your cutting boards, where let's face it, a lot of these pathogens do reside. We could talk more about that offline, but I'd like to bring the first highlighted topic here: standards for growing, harvesting, packing, and holding of produce for human consumption. This is commonly referred to as the Produce Safety Rule. This does set minimum science-based standards for the control and reduction of many of the potential sources of contamination from the growing community, the growing fields, the production environment. So the Produce Safety Rule is designed to reduce the inputs from each of these potential sources. And I will highlight today a little bit more about soil amendments, since that is the discussion of today. What you see here is a framework, and you can access this as well as the document called the Qualitative Assessment of Risk, which contains many of the science, much of the science associated with our rules and regulations in the Produce Safety Rule, called the Qualitative Assessment of Risk. The link here is active. This is a very high level structure of how we package risk in terms of least risky to most risky. I don't think anyone will disagree that human waste is potentially the riskiest soil amendment that you can use to grow fresh fruits and vegetables. And on the opposite side of the spectrum, we have non-biological elemental chemical fertilizers, which are not without risk. Of course, all soil amendments have a potential to not only disseminate foodborne pathogens in the environment where produce are grown, but also enhance the survival and persistence of any residual pathogens that might already be in the growing environment. I expect some of the scientists will discuss those concepts later today as well. So what does FDA regulate in the Produce Safety Rule? We regulate soil amendments of animal origin, and we have a whole subpart F, associated with how growers should approach soil amendments of animal origin. We have a new term for it. We call BSAAO, biological soil amendments of animal origin. In the subpart F, we regulate how these should be utilized for produce consumption, the production of produce. So in terms of treatment levels, treatments, we have scientifically validated treatment processes that we require certain documentation. If you would like to have 0 days to harvest restrictions on certain soil amendments of animal origin, we would expect those soil amendments to go through a scientifically validated treatment process. There are many treatment processes. There are heat, physical, chemical treatment processes. Any combination of these can provide a perfectly pasteurized and even microbiological sterile product if it's scientifically validated. Compost sits somewhere in the middle between an industrial process and raw manure. Of course, raw manure would be considered the most risky. If you're using raw manure and you are an organic grower, you're very familiar with the concept of application timing. The National Organic Program provides restrictions around not only how you can apply, so the application method would be, I don't believe you're allowed to surface apply raw manure. You need to till in your raw manure, but you must also wait 90 or 120 days after you apply that raw manure before you could harvest your crop. So the farther you can wait to harvest your crop after you apply raw manure, the safer that commodity is grown and will be. And that is a concept we are rapidly understanding a lot better now. Over the last 5 years, we have been working hard to characterize and understand foodborne pathogen survival and persistence in the growing environment when raw manure is used to fertilize a soil in order to maintain soil health and crop nutrient status. We're 5 years into a potentially 10-year program, and we're doing a risk assessment, which I'll talk about in a minute. But our efforts are designed to provide some sort of protection, which is currently reserved under the produce safety rule. We currently do not have any days to harvest restrictions on the use of raw manure. The only restrictions we do have for the use of raw manure is that you may not apply raw manure in a manner that directly contacts the commodities that you're growing. Until our risk assessment is complete, we say that until that time, when we do have a better handle on what provisions should be incorporated to maintain a level of safety that FDA is comfortable with for the production of commodities where raw manure is grown, we say that if you're following the National Organic Program 90 to 120 days to harvest, that is perfectly acceptable until further notice. So we haven't quite finished compiling all the data sets yet. Again, we're in year 5 of a potential 10-year program, but I'd like to highlight the progress we've made and what we're doing about it. Again, if you're making compost or you're buying compost, this product should not be considered a pathogen-free product, and compost must be utilized in accordance with the produce safety rule in terms of application method. You must apply compost in a manner that minimizes contact with your commodities. Compost cannot be blasted across an established bed of leafy greens because of the potential for residual pathogens in it. And we talk a lot more about this concept in our guidance to industry, which we'll talk a little bit about here. In our compliance and implementation guide, this is now draft form. We are, based on that, much thanks to many of your comments, we are restructuring and providing examples that are more applicable to your operations. We have 6 steps in Subpart F that we would like you to consider following in order to meet the minimum science-based standards, how to use raw manure and other soil amendments of animal origin safely. And again, I'd like to point out there's going to be a few changes, one of which, if I get my pointer working, microbial standards for your treatment process. This is sort of new language. We do not, I just want to highlight that we do not have microbiological standards for soil amendments. We have microbiological standards for treatment processes. And we talk a little bit more about this concept in the guidance. And I hope that the next version will make that a little more clear. So our risk assessment, what are we doing? We are conducting a series of experiments and collaborations with industry, academia, centers for excellence, and other government institutions such as USDA in order to understand one concept. That is, we're trying to quantify the risk of human illness associated with the consumption of produce when grown in fields where raw manure is used. So what does that mean? That means we need to get an understanding of what pathogens are currently in manure. So we have commissioned some work to understand the level and not only the presence, but the frequency with which you can recover Shiga toxigenic E. coli from dairy and cattle manure and salmonella from poultry manure. We've commissioned studies to understand, okay, once you know how many pathogens are in that manure, if you're applying that manure to different soil types and different geographical regions, what happens to the population over time? Good news is all the populations do decline over time, but we need to understand and accurately capture and characterize those populations in order to understand what provisions might best be suited to implement in the produce safety rule. So once we understand what level of pathogens are available in the soil and to which the commodities are exposed, we need to understand just how well those soil particles to which potential pathogens might be attached can transfer to commodities in which they're grown based on irrigation events, rain events, not only to commodities that are grown above ground, such as the leafy greens you see here, but also stem fruits, which are a little higher, as well as root crops. We're working on this concept right now. And then, of course, the final stage, which we already have a handle on, is just how do pathogens persist in after harvest when the commodities go through post-harvest processing, potential washing, and cold chain storage, as well as end up in your supermarkets and your home. So just want to highlight briefly the players. I expect you'll have more discussions later today in the subsequent seminars, but I want to highlight our efforts here and the main players involved. Dr. Michelle J. Russell will be speaking later today. I know about some of her work, but our first step was to understand what population size and what frequency with which pathogens can persist in different manures. And here you see some of our activities to understand that. Probably one of the largest data sets ever contrived to understand pathogen persistence in soils was done by USDA's labs. Hats off to Dr. Milner and Dr. Sharma for conducting and orchestrating a huge study to collect thousands and thousands of data points in different geographical regions and to characterize the pathogen persistence in different soils over time. You can see here many of the graphs that accurately characterize the pathogen persistence. Some of these pathogen populations go up and down and up and down. Some go up and down, some just go down. It's just absolute amazing how many different survival patterns you can find in different environments. So we were able to understand finally how different factors are associated, what factors are most important in persistence of pathogens through USDA's work. So thank you. And those data sets were crunched through the help with artificial intelligence. And this is very much in line with our new era in food safety. We're using machine learning to be able to take these data points and sets that were created by USDA in order to develop a model, a computer model that can accurately predict the survival patterns of these pathogens in different soils and different regions based on rainfall, soil moisture, and many other concepts and factors that we have in our paper we published earlier this year. Highly recommend you take a look at it. It's quite fascinating how we were able to do this. So now that we have an understanding of the pathogen persistence in soils and the population sizes through which in the manure that's added to soils, we're now at this third stage here where it's probably the most technically challenging to get transfer coefficients from the soil to the leaves. And so we're deep in this now for all root crops, low growing crops, and stem fruits. And I just want to thank you for your time and efforts in this arena and interest in this arena and your attention today and learning more about what FDA does, how we're doing it in order to understand how the safety of soils can affect the safety of the crops that we're growing. And not only that, but every foodborne outbreak we have has a negative effect on human nutrition in terms of consumer choices, commodities, recalls. It's just the negative attention to certain crops is huge. So we're working hard every day to prevent foodborne outbreaks, to promote and protect public health, and also soil health is a major factor. So this is a rapidly growing area of science for us. We appreciate your time. If you have any science projects that you're interested in, we can leverage our science to help you understand. I attached some web links there, and then of course every one of the good people on this slide are important to this effort that I'm presenting today. So I thank you for your time, and have a great rest of your day.